Hello students, welcome to water pollution section 5. I will see you guys next week. I am presenting at the Utah Science Teachers Conference in Provo. Woohoo, there's me presenting with Mrs. Swenson. Inquiry with brine shrimp cysts and photosynthesizing leaf discs. Everybody be impressed. Just kidding, it's not that impressive. They were practically begging people to present because nobody was presenting. So I decided to. And ooh, there you go. Take a look at my awesome presentation. Hopefully I won't bore them to tears like I'm probably about to bore you to tears with this presentation. Screencast, rather. Alright. To start off, we're going to take a look at this story about the dead zone in the Gulf of Mexico. This is the Mississippi River Delta, and it's got a watershed that has about 40% of the land area of the United States. This delta is where the watershed actually empties out into the Gulf of Mexico. And a lot of this watershed is in the agricultural heart of America. Farm production, this is in the later half of the 20th century, farm production experienced a huge boom, and more fertilizers were spread on fields, more animals were being raised on feedlots, and wetlands bordering river tributaries were drained, so they were no longer able to accommodate agricultural runoff. What happened is the soluble nitrogen delivered to the river tripled, pardon me, and finally ended up into the Gulf of Mexico. In 1974, marine scientists found areas where oxygen had disappeared from the bottom of the sediments. So you're seeing these red areas is where there were very low concentrations of oxygen. Oxygen not being present there is deadly for the bottom-dwelling animals and any oxygen-breathing creatures that live there. When there's no oxygen, it's called a hypoxic area, or the quote-unquote dead zone. They thought it was similar to other bodies of water like the lower Chesapeake Bay that received high nutrient levels, and they thought that it would disappear seasonally like it does in the Chesapeake Bay. But in 1993, when there were floods in the Midwest, this hypoxic area doubled, and it continues to grow. Over the past 5 years, this is since 2000, so from 2000 to 2005, it's averaged over 6,000 square miles. There's a lot of fishing and shrimping industry in this area, so they have learned to avoid these hypoxic areas. For a long time, they couldn't find the connection between nitrogen and the hypoxia. And finally, they figured out that nitrogen is a common limiting factor in coastal marine waters. If there's a lot of it, it promotes a lot of growth of algae, or phytoplankton, that live in the water. Then, other organisms that are zooplankton, little tiny animal-like, microscopic animals, they can eat and grow and multiply really quickly. Those two things, if the phytoplankton die and as the zooplankton create a lot of waste, that waste and dead stuff sinks down to the bottom as it's decomposed by aerobic bacteria. That aerobic bacteria then consumes up all of the oxygen, creating these dead zones in the Gulf of Mexico. So because this area is huge for fishing, it's a $2.8 billion per year enterprise. In 1998, Congress decided to do something about it. Imagine that. If they can make money off of it, they'll do something about it. They passed the Harmful Algal Bloom and Hypoxia Research and Control Act. Probably not one we'll have to memorize for the AP exam, but kind of a good one to talk about here. And they charged scientists with assessing the dead zone in the Gulf of Mexico. So the strategies that were key to helping solve the problem, and these strategies were presented as a question on the AP exam last year with this problem on the Mississippi. So the strategies would be to reduce nitrogen loads to the streams and rivers in the Mississippi Basin by using less fertilizer, restoring and promoting the wetlands that would retain the nitrogen and denitrification process of the basin, if you remember our nitrogen cycle. And that was the idea. Some of the money facts about this. This was a voluntary plan. It was dependent on funding from the U.S. Department of Agriculture. 5 years into the plan, the dead zone had shown no signs of shrinking, and a report from Environmental Working Group, they determined that for every $1 spent on conservation programs, 500 was spent on subsidies to farmers that encourage more fertilizer use. So I think they kind of shot themselves in the foot there. Alright, so today we're going to talk about water pollution. These are kind of the ideas that we're going to hit. Let's define pollution first. And then after we define and look at pollution, we will get into prevention. But today we're going to focus on just the definitions of pollution. So pollution, a substance in the environment that, because of its chemical composition or quantity, prevents the functioning of natural processes and gives undesirable environmental and health effects. So let's talk about the sources, the types, and the criteria for water pollution. These terms are what your text comes up with as what are called pollution essentials. Identifying pollutants and their sources, cleaning up areas, and developing pollution control strategies. These last three we'll touch on, not today, but next time. Okay, here we have the categories of pollution. We've talked about air pollution already, and the sources of pollution are in the middle. Pollution is an outcome of human endeavors that are usually, otherwise worthy endeavors. I mean, we need to grow crops, so we need fertilizers. We need to protect them from pests and from weeds, so we need herbicides and pesticides. We need things that are produced by industry. We need to get rid of waste. We all produce waste. We need a way to treat sewage, and we need a way to get products for our homes and for our buildings. But the key to this is to do this in a way that minimizes pollution to water. So the major categories of pollution are shown here, and I think each pie chart represents the biggest slice. Looks like it's from toxic chemicals for water pollution anyway. Okay, we looked at these already, so I'm not going to go over air pollution categories. But for water, some categories, like in the Gulf of Mexico, nutrient oversupply. Solid waste is something we'll deal with in our next unit. Toxic chemicals we're going to deal with in this and next unit. So toxic chemicals can be we've already talked about toxic chemicals in the atmosphere. They can be in the water, and they can get into soils. Pesticides and herbicides we've talked about a little bit before, but now we're going to get into this more, and we'll come back to this as well when we get into hazardous wastes. But pesticides and herbicides are a big deal for water pollution. They don't typically just dilute out of the water. They tend to concentrate in the tissue of animals and plants, and in a process that we call biomagnification. And then another minor one for water, it's not as big of a slice of the pie as others, but nuclear waste in water. And when Nathan presented on the Chernobyl disaster, and when we learned about Fukushima disaster, we learned how water can be contaminated by nuclear waste and the harms of that. Okay, let's look at point and non-point sources for water. Point sources are sources that are directly dumped into the water. Non-point sources travel through either soil and then get into groundwater and then eventually into streams. So point sources are a lot easier to identify than non-point sources. And sometimes non-point sources have to be traced to their source, so they can be identified and then prevented from polluting our streams and rivers. These are the types of water pollution. We'll talk about each of these pretty specifically. So pathogens is the first one. Pathogens are infectious agents that cause sickness and death. Usually it's the excrement from humans or other animals that contain pathogens, and they contain large numbers of eggs of parasites in the excrement. The most common waterborne pathogens are on this table right here. So several of those are caused by bacteria. We have a few protozoans. We have some multicellular goodies down here, and then a couple of viruses. And you've heard a lot about a lot of these different types of bacteria. You've heard of Salmonella, two different species here. You've heard of cholera before. You've heard of E. coli, and you've heard of hepatitis and polio virus. In fact, in the 50s, there was such a huge outbreak of polio that parents would keep their children from going to swimming pools so that they did not get polio. But now polio is not as common in the developed world as it was in the past because of the vaccine for the polio virus. Dysentery is severe diarrhea, like the kind that the excrement is bloody diarrhea, basically, and that can be caused by bacteria or protists. Giardia, you've heard of probably before, and then I'm sure you're familiar with lots of parasitic diseases like roundworms and flatworms. This is where I will pause, and you will see me shortly in part 2.